Okay, so I'm doing this egg osmosis experiment to show the difference between hypertonic and hypotonic solutions and their effect on a cell. So first off, the solution in the cups is white distilled vinegar, and for this experiment to work, we have to get the hard shell off the egg. So what the vinegar will do is eat away the hard shell, and then we'll have two eggs with just the membrane. So that can represent the semipermeable membrane that goes along with the cell. You know, selectively letting things in, selectively letting things out. You know, so we will wait for 3 days, and I'll come back and film the eggs, and we'll see you later. Hey everybody, this is part 2 of my experiment with the egg osmosis hyper and hypotonic solutions. Okay, so it's been 3 days and I've soaked the eggs in white distilled vinegar, and as you can see, it has eaten away the white shell, so now it's just like really squeezable and has an outer membrane and the inside still intact. So the two eggs just represent the cells with the membrane. Alright, so on the two glasses, one is filled with plain tap water and the other one I'm going to fill with salt. So that'll be salt water. So the one with the salt water will represent a hypertonic solution because it's more concentrated and it will have more particles in it. And the tap water will represent a solution that is hypotonic, so it's less concentrated because there's no salt. So normally in the human body, basically what we're saying is a more concentrated solution, the hypertonic solution, a red blood cell, if it's in a hypertonic solution with more concentration, the water tends to flow out of the cell, so the red blood cells will shrink and hemolyze. So what this is going to represent is I'm going to go ahead and add the egg to the hypertonic solution with the salt. So in about, let me go ahead and add this one into the plain water. So in about 8 hours, we should see a difference. We should see this egg has shriveled up some because the water from the egg is moving out because the salt is pulling the water out of the egg. And then this one in the plain tap water, we should observe that it will actually pull in a little bit more water, so it should weigh a little bit more than it does now. So we'll check back. I'm going to leave this overnight. That should be enough time for the results to come about, and then I'll film again in the morning and see what we've got. So alright, thanks. We'll check back. Okay, so this is part 3 of my experiment. Don't know if the salt water did any good, but I put a bunch of salt. So this is the one that was in the salt water. I don't know if you can see that really good, but pretty much, like, look how thin it's gotten. I can squeeze it, like, it's really, it did shrink, you just can't tell. So it has a lot more push to it. See how it shrank? And then this one in the plain water, it actually is heavier than the other one now, and it's more full, and when I press it, I can only squeeze it about this much, and then I get, you know, a lot of tension. So, which proves that the water, plain water, the water was pulled in to this one, and the salt water, the water was removed. So see how far I can push this one down, and not this one because this is fuller, but this one lost a lot of its water content. So this one was in the hypertonic salt water solution, and this one was in the hypotonic plain water solution. So that just shows you, you know, these can be compared to real cells in our body, and you know, about the sodium content and all that good stuff pulls water out, plain water goes in. Alright, thanks for watching.